Okay, so we're back. Let's continue with our recording. Question 35. We are going the answer is D. Okay. And the reason for that is that we are trying to describe the operation of valve VA. How does valve VA work? When the empty sensor for valve VA trips, it should open it. So the set for valve VA is your empty sensor I0.3. Okay, that's why that is coming into your set. And you can also have Q0.4 is the output for the lamp. Okay, so to the lamp comes on when you look at the question. Okay, the lamp comes on when S1 is pressed, the filling process is started and the lamp H1 comes on. So the lamp is to show that the filling process is ongoing. Okay, so when the lamp is on and your empty levels sensor is also has also been tripped, your SR flip flop for the valve VA can then set. Okay, now what can reset it? You have your stop push button and then your timer 2. Okay, timer 2 is for the closing of the valve VA. When you look at the question, you'd realize that when it is full, V0 closes immediately. Then after some time, which has been the time will be timed by T2. After that time, then the valve either VA or VB closes. Okay, so that's why the answer is D here. And for question 36, the operation of valve V0, question 36 answer is C. Okay. When you look at V0, what sets it? When it's opened by a timer. Okay, so the opening, um, when you look at the question again, you would notice that valve VA or VB opens. Then after T1 has counted some time, then V0 will open. So T1 sets V0. What can reset it? You have your stop push button, your I0.2, I0.2, which is your I0.2, which is your full water level for A, or I0.4, which is your full water for VB. Okay, so 30, question 36 is C. Let's move on. At an apple packaging section of a commercial farm, right? To cut the long story short, you have a conveyor running. Okay, when you press your start push button S1, you start a conveyor. The conveyor gets to a point, it stops for to fill an empty box with 200 apples. Then it continues moving. There's a sensor that stops the conveyor, and then there's a sensor that counts the apples into the box. Okay, so right now we are just using, now there are lamps. There's a lamp when the packaging process is ongoing, and there's a lamp when your stop button has been pressed, but then the packaging is still ongoing. Okay, so that's me paraphrasing the question. Now 37 asks the operation of the counter. Question 37's answer is C. Okay, how does this work? A second. 37's answer is C. How does this counter work? Okay, for counters, what sets the counter is basically what is starting the whole process, and then whatever is at the countdown is the one doing the actual counting. Okay, so what sets the counter is the empty box sensor, and our empty box sensor is I0.2, which is going to be at our set. I0.3, which is the sensor for apples, is the one counting the apples one by one. So that one will be at the countdown side. Okay, you put your preset value of 200 in, and you store it at a location M10.1. So question 37's answer is C. 37 is C. 38. Which of the following correctly describes the operation of lamp H2? 38 answer is also C. How does lamp H2 work? H2 is the lamp that runs when the whole process is ongoing. Okay, so for the process to be ongoing, that means that your conveyor is still running, your valve 1 is still working, or either your conveyor is running, your valve 1 is working, or your lamp 1, the lamp for when the stop button has been pressed. So the stop button is pressed, but the process is still running. That one too might have also been pressed. Okay, so those are the things that might show that the processes are still running. Okay, so that's why those ones are at our set. And looking at our reset, you have your I0.4, which is your emergency switch, I0.0 your stop push button, and then you have M10.1, the output of your counter. Okay, this whole process, when it's done counting, it can reset it. Okay, so when I want to read this to you. So when a stop button S0 is pressed, the box which is being filled must get 200 apples before the whole system can be brought to a stop. Okay, so the counter must finish its cycle before it can even end, no matter what, unless you are using the emergency switch. That's why the counter and your stop push button are in an end gate. So even if you press your stop push button, the timer also has to end its 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 cycle. Okay, so the answer is C. Question 39. Which of the following PLC programs correctly describes the operation of the conveyor? Question 39's answer is D. 39 is D. Let's explain. The conveyor starts with your start push button. When you press your start push button, your conveyor starts running. Okay, so that's where the set for the conveyor comes in. And let's look at the reset before we explain the relevance of your counter there. Okay, so I0.4 is your emergency switch, I0.0 overload, and I0.2 is your sensor for an empty box. So the reason that is at your reset side is that every time an empty box is sensed, we bring the conveyor is supposed to come to a stop. Okay, beautiful. It comes to a stop for the counter to start working to fill the box with 200 apples. Now when the counter is done, it sends a signal back into the conveyor that okay, now I'm done, so you can start moving again. That's why the counter is at the set side for your conveyor, because they will send another signal back inside that okay, now I'm done, so you can start moving. Okay, so that's why the answer for 39 is D. Question 40. Which of these correctly describes the operation of lamp H1? 40's answer is C. Okay, 40 is C. Now to explain. Lamp H1 is a lamp that comes on when your stop button has been pressed, but your process is still running. Okay, so when you press your stop push button, so the set to for lamp H1 has to be I0.0. Okay, so but then the process is still running. Your process is still running, so that's why you have your counter also in there. So once the counter is done running, it will end up resetting the whole thing and then turning off H1. So your counter is at reset. Okay, but then your stop push button is at set. It's at the set. Okay, now even though the answer is C, for now let's just say that the answer is C. Let's just end it over there. Okay, let's end it over there. Question 41. Which of the following PLC programs correctly describes the operation of valve V1? The answer for this is D. Okay, how does valve V1 work? Valve V1 opens when you look at the set for this I0.2, that is your sensor for empty box. So the valve starts when it notices that okay, there's an empty box here. So now I can start releasing 200 apples. Okay, so that's the set to your valve. What can reset it? It is the time, the counter that will reset it. So the counter, when the counter is done counting 200 apples, then your valve V1 closes. If not that, your stop push button has been pressed. But even if your stop push button is pressed, it has to finish counting. That is why your stop push button and then your counter in an AND gate together. Entering another OR gate which has your emergency switch which comes into your reset. Okay, so 41 is D. Now, an induction motor operates under the following conditions. When the push button S2 is pressed, the supply mains comes on, connected in star. When the push button S2 is pressed at least 5 seconds after the motor started in star, the winding connection changes from star to delta. However, if the motor continues to run in star up to 20 seconds and S2 has still not been pressed, the connection of the motor winding automatically changes from star to delta. The motor can be switched off either by means of the overload protection F1 or the stop button S0. Beautiful. Now let's look at the questions here and solve them. So which of the functional block diagrams describes condition 2? Okay. Which of the functional block diagrams describes condition 2? The answer is A. The answer is A. Sorry, the answer is C. The answer is C. Condition 2 for question 42. The answer is C. So 42 is C. Or wait, please give me a second. Yes, 42 is C. Okay, so now let's explain. This is from sequential control. Okay, so you have your condition, your initial condition, initial events, condition 1, event 1, condition 2, event 2. Okay, you would have to break this down on your own, but because of time, okay, but I want to explain what your condition 2 is. Okay, so your second condition for this one, your second condition is that your timer is now at 0, your timer is at 1 logic. Okay, so your timer 1 has gone to, one logic. Okay, and then your condition 2 will be described by M1.2. So your output is M1.2. That is correct for all of these ones. And then for condition 2, we want your M1.2 to be high. Okay, so 42, I said the answer is C. It's C. So you are looking at your I0.2 and T1 coming in with your T2. Okay. I feel like I've not explained it well enough. Let me take my time and say it well. So you have I0.2. I0.2 here is I0.2 is our overload, and T1 is your timer. Okay, so when you look at the question, you would notice that when your timer one is for 5 seconds. Okay, so that happens at your initial condition, everything is 0. The initial condition from sequential control is that all events are reset. Okay, for all of them, usually the initial conditions, everything has been reset, and then event 1 is that your mains is off, your star is off, your delta is off. Okay. Now your condition one. I keep on mixing up the two, forgive me. Condition one becomes now that I0.0, which is your stop, is now at one logic. Okay. And then your events, please forgive me, okay? Forgive me. I keep on mixing up the two. Conditions happen before events. Okay, so your initial condition is that all your events are reset, and then your initial event is that your mains are off, your star is off, and your delta is off. Okay, now your you come to condition one. Condition one is that I0.0 is at one logic. Okay, event one is that the mains is on, star is on, and then your timer has now been set to 5 seconds. Okay, then you have from there you have your condition two, which is that now your timer is at one logic. That means your timer is done counting. Okay, so your first 5 seconds has ended, and then now you have your event two. So condition two is that your timer has ended. So when you look at that, when you're looking at the fact that your event two is that the timer has ended, I feel like we don't have enough time to explain all of this. So you know what? 42, the answer is A. It's like this concept, I'm realizing that I would need a board to explain it, and we don't have one, and we don't really have the time. So for these ones, just choose the answers, okay? God bless you as you choose the answers, and let's hope it doesn't come. It won't come. It won't come in Jesus' name. It won't come. Question 42. So 42's answer is C. 43. Let me give you all the answers once and for all. So 43. Please 1 second. I'm stopping the recording again. Which question did I get to?